All right, so I'm gonna talk about generally what we have been doing and where we're going. So, and a lot of this is in videos that I've already posted for you all to look at. But here I'll kind of just try to emphasize what the big picture idea is. So we have this model of consumer behavior, which tells us that consumers are trying to maximize their utility when they're choosing what goods they're going to consume. And we say that's the consumption bundle they're going to end up with, their optimal consumption bundle. So we went from the consumer preferences generally to, and I have to play with this whiteboard a little bit, to the idea of the consumer's utility maximization problem. And if you're ever just chatting with folks and you're talking about the consumer choice problem, and instead you say consumer utility maximization problem, it's the same thing. They're not going to think that you misspoke or you're talking about different things. The utility maximization problem is the consumer choice problem. And you can have consumer choice in different contexts, but it's all the consumer choice problem ultimately, and it boils down to this utility maximization problem. So from there, what we end up with is these set of simultaneous equations. And I'll talk about the solution to the consumer's utility maximization problem a bit more, but I want to draw the graph for reference. And so the consumer is choosing between two goods, some good here labeled on the x-axis, and some other good here labeled on the y-axis. And their choices are determined by their budget. So we have this budget line, our budget equation, budget constraint. And then the consumer has this utility function over this consumption space, this domain in which they're choosing what to consume. And we said it turns out, because the consumer is monotonic, they prefer more to less, they're going to choose to consume at some point on the boundary or their actual budget line. That's what we mean by boundary. And their choice is going to be determined by the shape of their utility function, ultimately. And so they're going to end up choosing the highest level of utility, and that's what we call a utility maximization problem. And if we illustrate the highest level of utility that they can achieve with their budget, then the diagram we end up with has this contour plot of one particular level of utility, and that contour plot is what we called an indifference curve. And so we end up with this tangency between a particular indifference curve and one of the consumer's indifference curves, and where it's tangent with the budget line. And that gives us a single point that's both on the budget line and on this indifference curve. Now, I also want to point out that usually we would label this indifference curve as U star, where U star is the maximum level of utility that the consumer actually achieves with their budget, the prices, and their preferences. So, and the pink dot there represents the consumer's, optimal consumption bundle, which gives us a particular amount of X and Y, the two goods that they will actually purchase, right? So we end up with an amount of X and an amount of Y that the consumer will actually purchase. And so I'll just label those X star and Y star. Those are the components of the consumer's optimal consumption bundle as illustrated here. So, you know, why are we going through this exercise? Well, again, ultimately, what economists want to do is they want to predict consumer behavior. They want to, you know, as analysts or working for private industry or government, they want to be able to say, oh, if you charge such and such a price, you know, Mr. or Miss CEO, for your candy bar, your in-house economist, I can tell you how many of those you are likely to sell. So here's where we kind of, you know, transition. We've been working with supply and demand to something a little bit more practical, which is, oh, can we tell you something useful that maybe a regular business major couldn't tell you, right? Why did you hire an economist? And so, you know, if we collect our data, we measure things correctly using our theory, we can give a good answer to the question that the CEO or, you know, the head of our division might ask us, which is, if we, you know, decide to change the price of the product, how much of it's actually going to be purchased? How much can we sell? So we want to predict consumer behavior. And so that's kind of like, you know, the first, you know, payoff from our theory that we can do this sort of thing. And now what I'm going to do is I'm going to get rid of some of these things to hopefully not clutter the diagram. But so we've predicted with this initial problem, right? We've predicted one particular set of values, right? But I also told you that this was like a window into where do the points on the demand curve come from. So if you think about it, right, the law of demand, and I'll just illustrate over here, right? Now, if we talk about demand, right? So we would normally put Q down on the horizontal axis, but it's the quantity of a particular good. So I'll put QX, right? And then we graph that against price, which would be the price of X, right? And we have this, you know, downward sloping demand curve. And so it tells us at each and every price, let's see if I can, I wanted to actually make it in yellow, not blue, so do a little different. So at each and every price, what quantity and if, you know, you have individual demand curves and you have market level demand curves. And I kind of, you know, I'm gonna be ambiguous about which I'm talking about, just because it doesn't matter. The market demand curve is aggregated, which means you add up, right? It's aggregated from all the individual demand curves. So, you know, at each and every price, we can predict which quantity would be purchased in the market, what consumers would demand, right? So now for one particular set of prices, hopefully you understand, we have all the same information available in the consumer choice diagram that's needed for the demand curve. In particular, right, we have information, remember the vertical intercept and the horizontal intercept for the budget constraint. We have the price, right? So this is going to be income divided by the price of Y, and this point down here will be income divided by the price of X. So we have, right? We have the price of X, and let me talk to somebody really quickly. So how about you, German? How are you doing this morning? Okay. How about you, Daniel? How are you doing? Okay. How about you, Russell? How are you doing? Oh, we have a bunch of passive observers today, it seems. Okay. How about you, Tommy? Jeffrey? I'm going down the list. Okay. Andrew? Alex? Brian?
Yes. Oh,
yeah, I'm here.
Okay. Okay. I haven't talked to you, Andrew, so I'll talk to you. How are you doing, Andrew?
good, very good. How are you?
Okay, so, pretty good, pretty good. So are you following what I'm saying here? Because this is kind of important to get the idea. So notice, right? I have a value for the price of X down here, and I know how much X the consumer will purchase. All I have to do is, map that over here to some level of price of X and some quantity for price of X, and I have one point on the demand curve. Do you see?
Yes.
Right. So in the problems that we're working through, right, we also contemplate a price change. So I'll illustrate a price change here. Let's suppose that the price of X goes down. So that means you can purchase more X. And now I'll go ahead, and this will be a value I divided by some other price of X. So I'll say, well, this will be PX, and then let's just put a little tilde by it, a different price of X, right? So then if I resolve, so this is like walking through the problems on Ignition, then if I resolve the consumer's choice problem with this new price, new prices, and the income is being held constant, then I'll get another optimal consumption bundle, and it'll look like this. Okay. There'll be another tangency. And then we'll just call this one U double star. And I'll make this consumption bundle orange. Or well, I'll make it brown, that's fine. So the consumer, now we have really, so I guess I'll say this, Andrew. So 2 points make a straight line, right? Are you with me?
Yes.
Right. And so now I'll have a new level of of consumption of X, and let's make that one brown too, just to try to be clear here. So call it X double star, right? And so now with this, simple illustration, I have two prices for X, and I have two quantities of X, which means I have 2 points on the demand curve. Okay. And I could fill in all the points in the demand curve if I just kept resolving this problem with different budget constraints, right? Different levels of the price of X. Now, one of the things that I want to show you is, and let me just start a new whiteboard so we can be hopefully really clear about this. Okay, so now I'll consider 3 budgets instead of just 2, for just sake of clarity. So let this be the consumer's first budget at a high price of X, and there's their budget with a slightly lower price of X, and then there's the budget with an even lower price of X. And for each of these budgets, right, and drawing in the indifference curves will make the diagram really messy. So I'm gonna just skip that part of the illustration. But what I will draw is they're going to be then for each of these budgets, there's going to be an optimal consumption bundle, and I'll just illustrate them like this. That tell us what the consumer's choice is at each of the different budgets that they face. So is that clear, Andrew? Do you see what I'm talking about?
Yes.
Okay. And so we can then go ahead and I'll try to do a good job of this, but we can connect these points, and they may not lie on a line. Normally, this is the line that connects all of the optimal bundles for the consumer as prices change. It's called the price expansion path. Okay. And I'll just write it over here. Is the price expansion path. But notice that, again, each of these budgets is going to be associated with a different price for X. And we could write the different prices of X and illustrate them as, the change in the price of X being illustrated on the horizontal axis here at the points where the budget lines hit the horizontal axis, what we call the horizontal intercept, just as we did here, right? But in this case, we would have 3 different prices. And then we would have 3 different quantities of X. So the price expansion path is what we need if we wanted to construct a full demand curve here, not just 2 points. Now, if the demand curve is linear, the 2 points is sufficient, right, to find all of the other points. But if it's a nonlinear demand curve, we would just have to fill in as many points solving these different optimal consumption bundles for the consumer as a result of the different budgets, and get all these points on the price expansion path, at least in sufficient detail that we could reproduce the demand curve in whatever detail we wanted. So the main payoff to the consumer choice problem, the consumer's utility maximization problem, is that this is where the information comes from for the demand curve. In essence, right, we would have no idea other than just saying it was some sort of a phenomenon, right? At different prices, consumers pick different quantities of goods to purchase. And we could just observe that and write it down without having this theory. But we wouldn't necessarily have any good confidence that things like the law of demand apply or they don't apply in particular circumstances. And so this theory enables us to gather information, to construct the demand curves, and also gives us some insight into how consumers will actually behave if they're rational. So we can better predict what the demand curve should look like. And in particular, we're really interested in trying to figure out when the law of demand is an accurate description for consumers and when it's not. So that's the next part of our set of problems. So as we get to the bottom of the problems on Ignition, we start to talk about substitution and income effects. And that's when things change a little bit for us. So before we move on to talk about substitution and income effects, I'll just ask really quickly, does anybody have a question about what we're talking about so far? Is there anybody who is uncomfortable or doesn't know how to solve the consumer's basic choice problem? Okay. Any questions? No. Okay. So, and again, there are details on how to solve the consumer choice problem that are available in other videos. So again, we're just kind of talking about the overview of how, but if you all have any questions, then feel free to ask. So now we want to talk about substitution and income effects. Okay. And the importance of substitution and income effects is it tells us when the law of demand will actually apply. And so I just want to kind of review something that you all should hopefully remember from principles. And it's the issue of the income effect. And that is, some goods are, quote, normal, and some goods are inferior. And so normal goods, as you might imagine, means that the goods are behaving, people are behaving with respect to the goods as we would expect they normally do. And the way that it boils down to, in terms of describing the consumer's behavior, is that for normal goods, we say there's a positive income effect. And what we mean by that is that as the consumer's income increases, they tend to purchase more of normal goods. And okay, so let's see. So Celine, are you here this morning?
I am.
Hey, how are you doing?
Good, how are you?
Pretty good. I can just barely hear you. I don't know if you can speak a little bit louder, but
All right, can you hear me now?
yeah, I hear you. I hear you better now. Okay, thanks. So, so does this make sense to you? What we mean by normal goods? As income goes up, people tend to purchase more of them.
Yes.
Yeah, and I don't know if that's your experience or not. You know, it should be, because it's a normal situation. It's what normally happens. Most of the goods that you probably purchase most of the time are normal goods, and so I don't know if you agree. It agrees with your intuition, but do you ever think like, oh, well, yeah, if I made more money, like after I graduate and I get a great job or something like that, I'm gonna buy more X. I'm gonna buy more of this stuff. And I don't know if it counts. Do you want to tell us what would be in your set of normal goods?
That's of normal good. Probably like shoes. Like if I buy more shoes, if I had a bigger budget, but not right
Yeah.
now.
Yeah. So like shoes, clothes, food, regular stuff, you're probably going to buy more of, right? Cars, housing, all that stuff, right? Or normal goods. And then do you remember inferior goods are ones that have a negative income effect. And so for those goods, and I'll just put DI for the change in income, right? And when your income increases for the inferior goods, then for rational consumers tend to buy less. And I don't know if there's any stuff that you purchase that if your income went up, you just wouldn't buy it anymore. Do you have any examples?
If my income went up, I wouldn't buy any more. Honestly, I would buy a new car if my income went up. Because right now, yeah.
But remember, for an inferior good, you would buy less of something if it's inferior.
Oh, okay. I would stop going to the discount movie theater if my
yeah, right. So like discount movie theaters, bus tickets, right? A lot of times people would ride the bus because they can't afford a car. So if their income goes up, they'll buy fewer bus tickets. If there's something that you're buying like ramen because it's cheap to eat and your income goes up, you buy less of that. You know, maybe like a used car. Maybe if your income goes up, right, you're going to buy a new car. You're not going to buy more used cars. So there are lots of things that basically inferior goods are things that people purchase because they can't afford something better. And so there are lots of examples of inferior goods. Basically, almost anything you can purchase at the dollar store is probably an inferior good, because as people get more money, they don't tend to go to the dollar store more, right? I don't know, when you're rich and famous, Celine, are you going to be going to the dollar store?
To stay humble maybe, but
I mean, right.
I don't really plan on it.
Yeah. So yeah, normally, right, a lot of those things that you might purchase at the dollar store, you don't purchase anymore. Now, it turns out we talk about normal and inferior goods, and there's lots of really insightful and important work that's done for businesses and investment purposes in terms of dividing goods into normal and inferior, because it actually helps predict a lot about the profitability of companies in different circumstances. Like you might guess that in recessions, when people don't have much money, they tend to buy a lot of stuff at the dollar store. And that means dollar store stock tends to get higher when the economy is bad. And so if you know that kind of thing, and you know, like COVID, for example, or the Great Recession or whatever, then as an investor, you'll know, oh, okay, a recession's coming. I should shift my stock portfolio away from investing in Nordstrom's and Saks Fifth Avenue, and I should take that money and put it into the Dollar General and Walmart, because I'm going to make a higher return during the recession in places that sell inferior goods. And then when the economy is doing better, then you shift your portfolio back to investing in Gucci and other things, right? So there's a lot of work that's done classifying goods into normal and inferior and measuring the extent of these what we call income effects. But for our purposes, what we want to know is that for normal goods, the law of demand always describes consumer behavior accurately. But for inferior goods, sometimes the law of demand fails to describe consumer behavior. And in particular, there are goods, and we call them Giffen goods, that are a special category of inferior goods for which the law of demand fails. Okay. So for example, and this is kind of an important thing, and I don't know if this makes sense to you or not, but since you're chatting with me, Celine, I'll continue chatting with you for a minute, just to see if this point makes good sense to you. So you know what I mean when I say the law of demand, right, Celine? Are you still there? Okay, maybe I get somebody else, because you helped out. How about you, Scott? How are you doing this morning?
Doing well.
Okay, so you know what I mean by the law of demand, right, Scott?
Yeah.
Yeah. So tell us, give me your gut. Like law of demand means this.
Price of the good affects the quantity of the good that people desire.
Yeah, and in a particular way, right?
Yeah, as
So-
price goes up, will demand less.
Yeah, so if the price goes up, people will tend to buy less, right? And if the price goes down, people will tend to buy more. That's the law of demand, right? And a lot of times we say that very succinctly by saying the law of demand says that price and quantity are inversely related, right? So they move in opposite directions. But and think about it, right? It sounds like a pretty important idea, right? We call it the law of demand. So by calling it a law, it makes it sound like, oh yeah, this is what I should always expect to happen, right? But like, can you think of any other laws in science?
There aren't a lot.
Well, how about the first law of thermodynamics, or the universal law
conservation
of
of momentum,
yeah,
conservation of energy.
right, and I don't know if you've ever heard of the universal law of gravitation. The gravitational force between two objects is affected by their distance to one another and their masses. But the scientists in physics don't say, well, the universal law of gravitation applies sometimes, right? No, it's universal law. They like universe law. It's supposed to always apply, right?
You're not going to violate it.
Yeah, no, right? That's not. So normally when scientists call something a law, it's supposed to, be a law. It's supposed to always apply. But we have this caveat to the law of demand where we say, and also if you're going to illustrate a demand curve, right, it's always downward sloping because of the law of demand. That's the inverse relationship portion, right? Price goes down, quantity goes up, you have a downward sloping curve. Never get an upward sloping curve. But it turns out that the law of demand, like I said, it has this caveat. Sometimes we do get upward sloping demand curves. And so because it's an exception to the law of demand, economists are very interested and also concerned, right? If you're building a model with a bunch of different demand curves in it and you're trying to predict how consumers are going to purchase goods over the next 5 years and things like that, well, if your model assumes the law of demand and the law of demand is wrong with respect to some of the goods that you've chosen, then you could end up with errors, right? You could do a bad job. And so it's really important for us to understand a couple of things. One is, when the law of demand should apply. And then there's kind of like a background issue, right? So
with trends.
Well, what I was gonna say is maybe it'll help kind of crystallize the idea this way. If I say to you, Scott, okay, law of demand says if the price goes down, you tend to buy more. If the price goes up, you tend to buy less. And let's pick, I don't know, what's something that you buy on a regular basis? I don't know. Are you a smoker? Are you a drinker? What other habits do you have?
I give up a lot of habits now. I buy paper a lot. I buy paper.
Oh, okay. Okay. So, and actually, maybe that's a pretty good case. You mean like 500 sheets of paper for your printer, that kind of thing? Yeah. Did you notice that paper's kind of expensive? I don't know if you did or not.
It is.
Yeah. And so a lot of times to try to get a cheaper price in paper, I'll try to buy in bulk, like, get a whole ream of it or whatever. But, so if I go down to Target and I look for 500 sheets of paper in one of those packages and it's like $10, I might not buy as much, right? I'm imagining you, as if the price was $5, you would tend to buy more, right?
Yeah, stock up.
Yeah. So, or if you get it on sale, if you see it's on sale for like $2 for 500 sheets, you might buy a whole bunch of it, that kind of thing. So that's the law of demand. But what if I said to you, oh, Scott, the price is going to raise, it's going to increase from $2 a pack to $10 a pack, and then you tell me, oh, I'm going to buy more at $10 than at $2. Would you think that that's kind of odd?
Yeah, I was guessing the fear would be that's going to go to 20 next.
Well, yeah, and then if it goes to 20 and you say, and now I'm going to buy even more.
It's the fear of further
Well,
price increases.
Well, I don't know about if it's like you're giving an explanation for why,
Mhm.
right? You might behave that way, and I'm not gonna say that, you know, what you're suggesting isn't a good explanation, but there's something kind of odd going on, right? I mean, you normally think if the price of like gasoline goes up, people will cut back, but what if they actually started buying more?
The law would be violated.
Yeah, it would be weird, and you might think that the consumers are not being rational, right? So
Mhm.
remember, in economics, we gave this technical definition of rationality, and we're really interested in being able to explain to others, basically to defend our assumption of rationality, because so much of you know, economics is built on the assumption of rationality. So when things are odd, then oftentimes people think that rationality has been violated. And so we want to explain in detail here in analyzing substitution income effects that yes, we can have upward sloping demand curves sometimes, but that does not mean that our consumers are irrational. They're still, remember, our definition of rationality was rationality means that consumers have preferences that are, so I'll put it over here. In economics only means, you know, complete monotonic monotonic and transitive preferences. So what we want to show is that we can get upward sloping demand curves even with consumers that are otherwise rational. And you kind of hinted at you know, part of you know, an explanation is that there could be something else going on. You know, predictions of future price forecasts and things like that that cause people to act in a particular way. But we want to say, even in the simplest setting where there is no, you know, future price forecasting, there, you know, people are just buying as they normally would and not changing their predictions about the future and those things. But even in these very simple settings, rational consumers can, under particular circumstances, and I pointed out the circumstances down here, right? They can sometimes have upward sloping demand curves, and we want to be able to put more, you know, detail into the claims that I made here, which is for normal and inferior goods. You know, in particular for normal goods, we don't ever have to worry about upward sloping demand curves. They won't ever happen. So how are we going to do that? Well, we're going to go back to our consumer choice problem, and then we're going to describe things in greater detail. So we're going to consider how a consumer reacts to a change in price, And then we're going to decompose that reaction into a substitution effect and an income effect. Though I have to kind of, stick in a little detail here, which I think, you guys can learn the mechanics of what we're doing and you can learn how to interpret things properly, but you may not initially agree as you start to think about the problem in more detail with what the analysis shows. Okay. And the place where it's most confusing is that we tend to think of income as the budget. And there's a departure in the theory right here in this portion of the theory. So income and budget are not the same for income and substitution effect decomposition. Okay. And the reason for that is that we're interested in what you might have learned in macro. Okay. And that is, we're interested in real income. And you may have remember that real income is a measure of the standard of living, or sometimes you might call it purchasing power of the consumer. And so I guess at this point I would say, and Scott, see if this makes sense to you. In this sort of setting, what's a good way to measure the purchasing power or the standard of living of the consumer?
I'm not sure at the moment.
Well, when I talk about this, see if it fits with your thinking. When I talk about your standard of living, what do you think what does your standard of living mean to you? When you think about, do you have a high standard of living, a low standard of living? How would you tell the difference? What's it like to have a low standard of living?
To be measurement of assets.
Well, yeah. So it has something to do, like, so again,
Your
and
potential.
we'll put little air quotes around these things, but just to kind of get the point across. So if you were a poor person, there's my air quotes, poor, right? You would have a low standard of living, right?
Mm-hmm.
And what would that look like? What does it look like to be poor?
A lot of inferior goods.
Well, yeah, or you just don't have stuff,
Mm-hmm.
right? You might not have a house, you might live in a small apartment, so you don't have access to your backyard and your barbecue and your pool, right? Because you don't have that stuff. You don't have probably a brand new Tesla Model X in your driveway, right? You might be right. Yeah.
Did you get your name on the Tesla truck list?
I'm still waiting.
Okay. Okay.
So you might not have, you know, a new Tesla Model X in your driveway. You might not be taking an airplane trip, right, to go to Europe to tour, and you know, is there any place in Europe that you want to go to in particular, Scott?
I'd go anywhere in Europe.
Go to Florence.
Florence.
Florence, yeah. When you get a chance, and I can also highly recommend the Basque region of Spain. Biarritz in France. Yeah, it's on the border of France and Spain. Anyway, you'll like it. But if you're poor, you probably wouldn't be doing that kind of stuff, right? You wouldn't have as much stuff, right? And I mean, are you agree with me?
Yeah.
And in our models, that would affect, remember, your utility is dependent on how much stuff you have, right? Ultimately, your utility, remember, utility is this function, and in our case, for Cobb-Douglas, x to the a times y to the b, by the beta power, right? But notice utility, does utility have prices in it?
No.
Does it have income in it?
No.
Not dollars, right? Not your budget. It has quantities of stuff. So what economists are saying is that if you have a high standard of living, you'll have a lot of stuff, and therefore you'll have a lot of utility.
Makes sense.
Does that make sense?
Yeah, that fills it out.
Yeah. So over here, the way that we're going to measure standard of living for income and substitution decomposition is that your utility is going to be a measure of your real income. And if you accept that, if my explanation made sense why we're doing that, then all of the procedure, the mechanics of doing the income and substitution effect decomposition will make sense. But if you never make this connection that utility is a measure of real income, then the mechanics don't make sense. Okay, so that's just so I'm going to go through the mechanical part of the income and substitution effect decomposition really quickly here at the end of the class. And then remember, there are additional videos if you require more explanation. And these are the last two problems 19 and 20 on the Ignithium homework. After we finish with this, we'll go back into review. And again, remember, we're going to be looking for another midterm exam here in the beginning of November. And I'll give you guys a specific date, but we're wrapping up this stuff. So, okay. So let's talk about one case, which is, here's your consumer original budget. Now, suppose they have a increase in the price of X. So that increase in the price of X, again, I don't want to clutter the diagram because there's going to be a lot on this diagram. But I'll just remind you that we can always see the price of X on our diagram by simply looking at I divided by PX as being the horizontal intercept. for the budget line. So implicitly, here is the low price and the high price, or the low price and the high price of X. Now, I will come back and I'll add these labels in later when it becomes more important, but for right now, I just want to leave them off. And then we know that the consumer, we said this outer utility or this outer budget line was going to be their original price of X. And we know that their optimal consumption bundle, then we can illustrate as a tangency between this original budget line and a particular indifference curve. So I'm going to call the value of utility here U star 0. I'll leave the 0 off right now, but I have just a 1 star there, so you know that's their original level of utility. And then we'll have some original optimal consumption bundle. And I'll illustrate it here. Okay. So, and that's going to give us their X star, their Y star, again, their before the price increase, it's their original optimal consumption bundle. Now, they have the increase in prices, and they'll have this new optimal consumption bundle. And this will be at a new and a lower level of utility because it's closer to the origin. And so I'll call this one U double star, okay? And okay. And then, so normally when we do the income and substitution effect decomposition, we're just interested in analyzing the impact on the change of X because we're contemplating a change in the price of X. So I'm going to put X star here, and sometimes I put X star 0, but I'm going to leave the 0 off. Just to, the 0 is supposed to be so you know that that's where you're starting. And then this is X double star. Okay. So we know that as the consumer faces these higher prices, that the consumer is going to reduce their purchases of X because of the increase in price, and that's fine. But what we really want to do is say, okay, some of this total change, and by total change, I mean total change in X, right, is going to be the difference between X double star minus X star. So some of that distance is going to be due to a substitution effect, and part of it's going to be due to an income effect. And so we want to be able to isolate the substitution effect from the income effect. And so I'm going to say, I'll say the total effect can be decomposed into a substitution effect plus an income effect. And so we want to get these magnitudes for the substitution income effect. So the question is like, well, how do we do that? And the answer really is in our definition of the substitution effect. Okay, so I'll put the substitution effect here. The substitution effect is the change in purchases of X due to the change in the price of X. And then here's the kicker, holding real income constant. So this is, and since you were talking to me, Scott, I'll talk to you just a little bit more. So do you understand that the substitution effect has this restriction, holding real income constant? Does that make sense?
So you're holding a utility constant?
Yeah, that's right. So holding real income constant means holding utility constant at the original level of utility. And so the diagram might look different depending upon whether it's a price increase or a price decrease. Here we just we're just doing the example of a price increase, but a price decrease would look the opposite, because the level of utility that we would mark as U star, the original level of utility, would be different for the consumer. But yeah, so holding real income constant. And then the other part I wanted to point out is what it's asking us to do is what you would commonly hear referred to as a counterfactual analysis. Does that make sense to you? What is a counterfactual analysis?
So looking at an exception to, so I was looking at something that appeared to be an exception to the law. I'm trying to understand why.
So I appreciate where you're going with that, but I really want to dwell on this notion for just a minute. The language, right? And I'll put it here. Maybe run out of colors, but we'll try brick red. This is a counterfactual analysis. So this, what does it mean when I say counterfactual?
It stops is happening what we would assume, what we know.
Yeah. So the facts are what's really happening, right? It's the consumer in the first instance has particular prices and particular income levels and particular preferences. And in truth, right, the consumer chooses that, right? That's the fact. And then the price changes and the consumer chooses that. That's the fact too. Counterfactual means like what the consumer would have done, right, if things had been different, right? Well, what's the different thing the consumer would have done? Which one are we interested in? Well, we're interested in looking at the change in price, holding real income constant. That's nothing that the consumer ever contemplated. It's a fiction, right? So we're constructing a fiction, and the fiction we want is we want the price of X to be at the level after the price change. And so I'm going to clean up some of this stuff really quickly, right? So how do we know what's going on with the price of X? Well, here, remember, we can look at these values of the intercepts of the budget lines, and that'll tell us what happened with the price of X. So here I'll put it's income divided by the price, and I normally call this PX1. It's what the price of X is after the price change. And then over here, remember the original consumer choice problem was I divided by PX, and then we could put like a 0 there, right? And what I want to do is go ahead and try to clean some of this up. So I'm gonna get rid of that X. Okay, so we're going from PX0 to PX1, right? And remember that the slope of the budget line is the price ratio. So the way we're able to express the counterfactual is to say, okay, we want to look at a budget line that's on the original indifference curve, has the same utility as what the consumer achieved before, but what the consumer would have picked if they faced the same prices as they faced originally. So, okay, you with me, Scott? Are you there?
Not quite sure. Say one more time.
Okay.
So I'm trying to clean up
okay.
my graph too at the same time.
Yeah, okay, so check this out, okay? So you see this green budget line?
Mm-hmm.
Notice that it has the same slope, or it's supposed to. Hold on, let me make sure it's parallel. Has the same slope as the new budget, right?
Mm-hmm.
But so that reflects the new prices. That's the reason the slope is different. So we're gonna say, okay, let's take those prices and enable the consumer to get the same amount of real income or utility that they got before. And so I'm going to look at this new tangency between this fictitious or counterfactual budget and the original utility function. And then I'm going to say, if the consumer was able to afford the same amount of utility, but face the new prices, then what would they have chosen? Okay, so it may take a minute for that to sink in, but I just want to make sure that this is clear. Are you with me, Scott?
Yeah, so you're holding utility constant, and now
Yes.
you're finding it would be the new quantity of X.
Yeah, well, and there would be a change in the quantity of Y potentially too, but we're just focused on X because we're just going to measure the substitution and income effect on purchases of X.
Okay.
Because we're changing the price of X, so we're not really worried about Y. But yeah, so we're gonna hold real income constant by holding utility constant at the original utility that the consumer achieved before the price change. And then we're going to say if the consumer can still get this level of utility, but they were to face new prices, like the new price of X that they faced over here, then what would they have chosen? And so in terms of focusing your attention, I want to point out that you'll have one indifference curve, the original indifference curve, and in your analysis, it will have 2 points on it. And the change in X moving from, in this case, the pink consumption bundle to the purple one, that's going to be the substitution effect that we want to measure. So I'll just kind of illustrate here. So you see how the level of X associated with that purple budget, and I'm going to get rid of some of the stuff down here too. I'm going to move the price of.
I wish I could do that with my graph.
Yeah,
I'm just
well,
putting on layers at this point.
yeah, well, this is kind of like a complicated scenario where you might need a couple of different graphs, like relating this stuff, because it's hard to put it all in one graph. I mean, I can do it when I'm drawing on the board. I don't have too much trouble, but the graph is very busy looking. So don't be disappointed if that's what you're dealing with. So what I want to point out too, and I'll try to illustrate this more clearly, is so we have some original level of X, which is our X with 1 star, right? And I'll try to move it on the graph, right? And so, and I'll put this little equation here and I'll make it in pink. Maybe it'll stick out then. I'm going to call it DXS, right? Which is going to be XS minus X star. That's this distance. And maybe I'll do it in bright green. It's going to be this distance right here. Can you see that, Scott?
Yes, Ken.
Okay. So that is the impact of the substitution effect on the purchases of X. Okay. And so a lot of times on a graph like this, what you'll see is that distance will be pointed out, and then there'll be a little label, and that'll be labeled as the substitution effect. Now, the remainder going from in the X dimension from the purple dot to the orange dot, that the rest of it is the income effect. Okay, so I'll go ahead and just illustrate it here, right? So that distance there is the income effect. And it's the income effect on the change in the purchases of X. Okay. So that's the basic way that we illustrate the decomposition. But I want to do one other thing, and this just is by way of helping you to be able to solve the problems. So you may remember, and I don't know if you do remember, Scott, right? So for the consumer choice problem, right, we have these two simultaneous equations. Remember, we have the budget equation. Does this look familiar, Scott?
And then tangency condition.
Yeah, and then the tangency condition, right? So for and I'll just do this really quickly, and then hopefully it'll make sense. For the substitution income effect decomposition, you also have two equations, okay? But your first equation is going to be the real income held constant, And your second equation is going to be, and this should be tangency. It's going to be tangency. Okay. And and I just want to focus on the tangency condition first. So the tangency over here, we said was the marginal rate of substitution is equal to the price ratio, which we said was PX over PY, okay? Over here, we have to be careful because we've got two different price levels to consider, okay? So our tangency condition is going to be a little bit different. It's going to be the marginal rate of substitution, just like we had before, but it's going to be PX, because the price of X changed. It's going to be the new price of X, which we called PX1 divided by PY, okay? And the real income condition is somewhat simpler, but it's just, we have a value of utility, which is U star, and we have to find out what that value is. It's, again, like a measure of the standard of living, but it's going to be an actual number. And then we're just going to use X to the alpha times Y to the beta. And so with these two equations, we have two equations in two unknowns. And the unknown that we really care about is the value of X that comes out of the substitution income effect decomposition. And what that's going to tell us when we get finished, when we find out the value of X that satisfies these equations, it's going to be our XS. So we can do our decomposition with the other information that we have. So I'll put a little heart above that one, because that's what we're looking for. So you can go ahead and watch the other videos. I know it's a lot, these last two problems, 19 and 20, and all together with all of the graphing and everything that you're going to do of the income of substitution effect decomposition, I would say that like 20% of your grade on the next midterm will be directly related to this income and substitution effect decomposition. So we'll spend some more time on it next Tuesday, particularly in the activity before class, working on solving those problems. But you technically, after this diagram and this setup, you have everything that you need to solve those last two problems. It's just that you got to work through it. Okay, so